Since it is already 10 minutes left for this class usual starting time, so I am going to start. And as per regular practice and the instruction, I am going to introduce myself before starting the class. So I am Sripan Mandal. I am working in IIT BHU as a research scholar, and I am going to deliver this week's the 6th week lecture for as a part of my PMRF deliverable. So as per regular practice, I am just trying to solve the assignments which have been given in the previous year for this particular course, and I think attending these sessions will help you to solve the questions given in the current year assignments. So let's move on to the first question. So till now we are discussing about some integration methods, especially the Monte Carlo integration, and we see the areas where they can be applied while we are studying the statistical and quantum mechanics. So right now we are moving on to the solution of differential equation numerically. So whenever we are starting any thing, so the first thing is we can take a example which we can solve by analytically also, so that we can check whether our program is good enough to have the values what we need to evaluate. Okay, so for this we have the first question, that solve the differential equation dy dx equals to 1 plus y square from the interval 0 to 1.46 using Euler method, modified improved Euler method with dx, the interval between in the x direction, or more generally in the independent variable to be 0.001, and then carry the same calculation using Runge-Kutta 4 method with dx being 0.01, and the initial condition is given to be y equals to 0 at x equals to 0. We need to save the data in 4 different files for 4 different methods, and as you know, if we solve this equation analytically, we will get a solution like y equals to tan x, and if we put the x equals to 1.45 at this equation, we will get that okay, at x equals to 1.45 y will have a value of this. So the solutions obtained using Euler, modified Euler, improved Euler, and RK4 methods will be referred to as this way. So now answer the following questions. So the first question is the value of the difference ya minus ye at x equals to 1.45 is. So what will happen, that we have this value from the question, that ya should be 8.23809, and we have to evaluate the value of y at x equals to 1.45 from the Euler method, and then we have to take the difference between them and check which of the option is correct for this question. So I am going to show how we can do this question. Okay, so just a second. So here you can see that here I am written a program for Euler method, and as you see I am calling implicit NaN as usual, and then I am giving the values, the type of the values like I, and in number of iteration enter, they had to be the integers, and I am defining a parameter set dx as per question to be 0.001, and then I have defined other variables also to be double precision, and then the initial condition to be x equals to 0 and y equals to 0 at x equals to 0, and then I have defined the x start and x end, and which are given in the question, that x will start from 0 and will end at 1.46. From there we can calculate the number of iteration by this value, x end minus x start by dx. So the total interval divided by a step size. So that will give you the number of intervals. And then we are prompting our command prompt to put the value of y at x equals to 1.45, which we can get by analytically, and that will be read as ya. And then we will print also the nitre. Okay. Then we are opening a file in which we are going to store the values we are getting for the x and its corresponding y. So how it can be calculated? Okay, so first of all we need to get back to the basics of how a differential equation is solved. So just a second. Yeah. So let's say you have dy dx equals to some function f of xy. So how you can write it, that y minus say y naught to be the reference point, and x minus x naught equals to a x y, right? So from here we can calculate the y if we know the value of y naught and this step size x minus x naught. So y equals to y plus, if we define this x minus x naught to be dx into f of x y. In our case f of x y is 1 plus y square. So in this way, and also this is an approximation, because if we expand it in the Taylor series there will be higher order terms of dx, but we are neglecting that for this method. Okay, so in this way we can calculate this. So what we have to do, we have to assign a value of y naught at x equals to 0, and then dx is given. Fxy we know the term. Okay, so in this case we have to find out y at different values of x iteratively. Okay, so let us look at this program right now. So here you see in this program, so if xy is defined as 1 plus y square as per question. So this line is defined as the fxy, and then this line is adding the y values for a particular x value, and then I am putting those x values in and y values in this file euler.dat. Okay, and now as per question, what we need to know is if the x value is equals to 1.45, then we have to print the value of y at that value of x, and which I am going to get by this if statement, that if deep float I, since I is an integer, then I into dx will give us that particular value of x after ith number of iterations, and if that is going to be equals to 1.45, then we will get the value of y to be our required value for this question. And since we know the y value, then we can have the print value of difference ya minus ye, which we need for our answer for this question is ya minus ye. So that this will give us the answer for this question. So let us look at how this code is going to be run. Okay, so here is my terminal, and I am going to write using gfortran euler.f. It will compile, and then I will go /a.out, and I have to give the value which I am getting analytically for x equals to 1.45. so that is, as per question, is 8.23809. so 8.23809. okay, so here you see we have the value of ya minus y, which is to be 0.1418. Now let us move on to the options, and this is 0.141. so this will be the correct answer for this question. So if we move on to the next question, so that will be, yeah, that is the program for the first question. Now you have to calculate the same thing using the modified Euler method. Okay, so in modified Euler method, what we basically modified is the slope which we are going to take for calculating the value of y at a particular value of x. So instead of taking the initial slope, we are going to take another slope which will be much better than the slope we are using in the Euler method. So how do we get to go to do that? So let's move on to this programming. As before, I am going to define all the variables like this, and also I am going to check for the value which I am going to get analytically, and by then I also open a file, and then here you see this block has to be understood. So what I have done is, initially I have given fxy is y square plus 1, which is as per question. Then I am updating a value in y1, that y plus dx into fxy plus 0.5 d0. okay, so what it is, that let's say we have a value of y1 which will be y plus dx, which will be the step size, by 2 into f x y. okay, so this will give you the y1 value, and then what I am going to do is I am going to update the slope like this: f1 xy equals to, now instead of taking y to define the slope, I am taking this value of y1, so y1 square plus 1 I am going to take, and then finally I am looking for that usual calculation, that y equals to y plus dx into, this time instead of using fxy I am using fxy. okay. So let us look whether this modification is for the sake of our calculation, okay, or the evaluation of value of y. So how can we measure whether it is good approximation or not? We have to look for this difference. If it is decreased from the difference what we are getting by Euler method, we can tell that yes, this modified Euler is better than using Euler method. So let's again go to terminal. Now instead of using Euler, I am going to write cfortran modified Euler.f. okay. So again it is asking for the value, so I am going to 8.23809. that will give us the answer 3.53 10 to the power minus 4. So if we look for the options, we will have the option like 0.0003, that will be 3 to 10 to the power minus 4. okay, so the answer for this question will be 0.0003. So okay, so now let us move on to the next question, which is the improved Euler method. So in this method, what we are going to improve, that the slope will be evaluated in a different way. So instead of moving dx by 2, we are moving here by dx, and then I am going to calculate at that point the slope, and also I am going to calculate the slope at the initial point, and then I am going to average out of those two slopes to get the slope which we will use for advancing the value of y as the iteration progresses. Okay, so let us move on to the algorithm. So everything is similar to the initial two programs, just the changes here. You see, if xy is given us as per practice, that y1 plus y square, then I am going to get this y1 like that, and I am going to assign that one. See here, I am not going to multiply this by 0.5 or 1 by 2. So here I am evaluating the slope at a value which is x plus h, not x plus h by 2. Okay, so f1 xy is calculated here, and then what I do again, f2 xy is the average of those two slopes by fxy plus f1 xy divided by 2. That will give us that slope which we are going to use for advancing the value of y in this line. Okay, so as per the other questions, I am going to use this if statement to find out the value of y. Well, that x value is 1.45, and therefore the value of difference will be calculated. So let us look at the output of this program. G Fortran improved Euler-Kutta. Here you see, this is 2.13 into 10 to the power minus 4. So it is lesser than this value also. It was 3.53 for modified Euler, but for improved Euler the difference is less than that also. So if we look for the options, then let's look for the options which will be correct. So for this, see that 0.0002, this will be the correct answer for this question. Then if we go to the Runge-Kutta RK4, we will get another answer. So in this case, remember in the question it was given you have to take the steps as to be 0.01. While you are using the Euler, modified Euler or improved Euler, there the dx is 0.001, but here in RK4 you have to use dx equals to 0.01. okay, and here you, so the formula is like this, that y equals to y plus h by 6 f1 plus 2 into f2 sorry, you can use this f0, this will be f1, this will be f2, and f3. This will be the formula which will update the value of y. So as before, I have defined all the initial conditions, and here look for the change in this program. What I am going to do, initially I have the value of y, and I am going to calculate f0 from that, and that f0 is used to have a value of y for this program y1, and that y1 is evaluated at a value of dx by 2, that means at x plus h by 2. So that y1 and then taken for calculating f1, and the f1 which I am going to calculate, that is used here for calculating y2, and that is also calculated at x plus h by 2. Okay, so that will give you the value of f2, and then that f2 is used for calculating y3, which will be calculated as x plus h, not x plus h by 2. Okay, so that will give you the f3 in this case, and then I am going to update the y in this way as per this equation. Okay, and then I am going to write those values in the file, and as before I am using this if statement to find out the value of y at the particular value of x as per question, and then find out the difference. So if we look for this, Fortran rk4.f, so dot slash a dot out, again I am going to give the value of 23809, so it will be 2.17 10 to the minus 6. So it is not exactly matching the solution or the options given in the question, but the order is almost same for this one, so this will be the correct answer. So let's move on to the next question. Now instead of solving the first order equations, if you solve the second order equation, say d2x dt2 equals to minus sin x. So if we write it, dt2 equals to minus, let's say f x t. Okay, this is the general form of the second order differential equation. So what we can do here is you see d2x dt2, this is essentially the acceleration term if we talk about the physics. So dx dt, that will give you the velocity, right? So in that case, this is itself a differential equation first order, so which we can solve as per the methods which we have already studied. And as soon as I have substituted dx dt equals to b in this equation, so I'm going to get dv dt equals to minus f x t, right? So this also reduces to first order equation. Now, and second order differential equation is reduces to two first order equations coupled with each other. So how we are going to solve them? So we can solve them by Euler, modified Euler, improved Euler also, but as per question this is given to be solved by RK4 method, and here we have to take the integration interval to be 0.01. Okay, and we have to calculate or run the iterations for 5000 times, and we have to find the value of x at the end of 5000 iteration. So how we are going to do this? So let's move on to the algorithm part. So here is the algorithm. Sorry. So here is RK4 coupled, and I have defined that f0, f1, f2, f3 for calculating the slopes in terms of x, and f0 v, f1 v, f2 v, and f3 v in terms of slopes for velocity. Okay, so initially I have been given all the values of x, v at t equals to 0 as given in the question, as well as the number of iterations as given in the question in this manner. Okay, so in this manner, and then as before, I have opened a file in which I am going to store all the values for the time and the velocity, as well the displacement at that particular times. Okay, so what I am going to do is that f0 is p. Why? Because I have already seen that dx dt equals to v. So this is our f0 x, right? Or if fxy or fxt, so this will be v. So I am going to assign this, and I am using that f0 value to update my x1 as for the previous question. So you see, again I am calculating this x1 at a value of t plus h by 2 or del t by 2 dt by 2. Okay, so again, so f0 v is given to be minus sin x as per the question. Okay, so what does that mean? That we have another equation which is dv dt, that will be minus sin x. Okay, so I am using this equation to calculate the slopes, and then that slope is used for updating the value of v at t equals to h by 2. So we have already updated the value of x as well as p at a value of t plus h by 2. Okay, and then I am going to take those v1 values and as well as the x value at that point to calculate the slopes in the second time. Okay, so here you see f1 is given to be v1, and then x2 is calculated by using that f1 which we are going to evaluate it from v1. Okay, so that is also calculated at t plus h by 2. So again, f1 v is calculated in the same manner, but this time with the instead of using x, I am using the x1, which is the updated value in the first step of the iteration. Okay, and then I am going to update my v value also using the v1 f1v. Okay, so two times we are updating already we have updated two times the value of x as well as p, and then the second times updated value v2 is taken to be the slope of the f2. That means the for this equation. Okay, and successively that f2 is used for calculating the value of x. Okay, to advance the value of x, and f2v is this time calculated by x2 instead of x or x1, and then v3 is calculated by v plus d2 into f2v, right, initially. Now mind it here that I am not going to use t plus h by 2 here. I am using t plus h while we are calculating the slope for the third time, right? And then I am going to give that f3 equals to v3, and f3v is minus 1 into sin x3, so that means minus sin x3. Okay, so I have all the parameters now calculated, and then I am using the usual formula by which we can calculate the x and v, right? So here you can see again x equals to x plus dt by 6, right, and in the bracket into f0 plus 2f1 plus 2f2 plus f3, so that will give you the RK4 equation. And similarly for v, I have used all the things, but this time not f0, f1, f2, f3, I have used f0v, f1v, f2v and f3v. So what we have is two coupled equation which we got from separating not separating the variables but assigning the variables in a particular manner. For example, dx dt to be equals to v. We have given that a second order equation which we transform into two coupled first order equation, and then I am using the RK4 method to find out x as well as b, that means displacement as well as the velocity. And so I have written those, and then as per question we have to print the value at the end of 5000 iteration, and then I am just doing this. Okay, so let's move on to find out what is the output of our question of our question as per the values of the given values for x, b and neither. Okay, so just a second. So yeah, so what we have as our program is RK4 coupled. Okay, so G Fortran, right, RK4 coupled dot f, so dot slash a dot out. So what we need to do, we have to assign three values here. At x equals t equals to 0, we need to know the value of x, v, and we have to give the value of iteration, number of iterations, which will be 5000. So 0.1, 3.1 and 5000. So these are the values, right? So x value will be 0.1, this will be 3.1 and this will be 5000. So I am getting this value to be 136.15, right? So if we look for the solutions or for the options, so here you see 136.15 is there. So this will be the correct answer for this question. Now we have another question with the same thing, but this time we have the value of v0 to be different. Initially it was 3.1 in the previous question, but this time it is 0.5, right? So again I am going to calculate this using 0.5. okay, so again I am going to compile this and dot slash a dot out, the value of x at 0.1, then this will be the value of 0.5 as per the question. So the number of iteration is same as before. So here you see we are getting this value of minus 0.405. okay, so let us move on to the options as given before, and here you see minus 0.405 is there. So this will be the correct answer. So these are all the questions which are given in the previous year's assignment for the week 6, and I have solved all of them one by one. So you can check this lecture while I will upload it in the YouTube. Okay, so thank you very much everyone for your kind attention. Hope I will be able to help you in solving or learning how to write the programming for the differential equations through my this lecture and the upcoming lectures. So thank you very much.